Okay, we're still in section 1.1. We're in the third part. This third part is going to talk about drawing actual angles correctly in trigonometry. Remember, from geometry class, you've only drawn an angle from 0 to 180 degrees. So first of all, you've only drawn angles that were positive in measure. We're going to talk about today how you draw angles in trigonometry, because an angle can be any size, which means it can be positive and it can be negative. So if we look at our worked out notes, okay, the first thing we're going to talk about is how do you know if an angle is positive by looking at the diagram. Well, first of all, anytime we draw an angle in trigonometry, it's going to say it needs to be drawn in standard position. Well, what does that mean? Standard position means a couple of things. First of all, it's the placement of the vertex point. The vertex point in standard position will always go at the origin. The second thing is, to draw an angle in standard position, you have to put at the first ray, which we call the initial ray. So the starting ray is called the initial ray, and that will always go on the positive side of the x-axis. So your initial ray will always go on the positive side of the x-axis anytime you're drawing an angle. Now the terminal ray will rotate. You have two directions that ray can rotate. It can rotate counterclockwise or clockwise. Okay, so think about the hands of a clock, an old-fashioned clock, the hour hand and the minute hand. Our initial ray, the one we begin with, will always go on the positive x-axis, but that terminal ray, that minute hand, is going to rotate. If we draw a positive angle, that terminal ray is going to rotate counterclockwise, which is in the opposite direction of a clock. So if here's your initial ray, and you start ticking with the hand, it's going to go counterclockwise. So if I put it here, that would be the terminal ray. And I'll show that rotation by putting an arc. And that arc symbol is very important, because if you don't put that arc symbol, I don't know which way the hand rotated. And that's going to be important. So we draw a positive angle, vertex is at the origin, initial ray is always on the positive x-axis, terminal ray will rotate counterclockwise. Now, believe it or not, you can have negative angles, okay? Any of you that are going to go into the study of health, when you talk about somebody getting knee surgery and rotating, moving their knee, their leg with their knee, you're rotating that piece of your leg, and that's making a negative angle because it's going backwards. So we're going to talk about negative angles. To draw a negative angle in standard position, again, vertex point goes to the origin. Initial ray is always on the positive x-axis, but if it's a negative angle, that little hand clock is going to rotate clockwise. So here's my initial ray. My terminal ray would rotate clockwise. And I would show that by making that arc with the arrow to show it went in a negative direction. Now, these angles that we're drawing, we don't know their angle measurements. So we have a letter of the alphabet we use to represent that unknown angle. I know in algebra we always use for unknown the letter X. In trigonometry, when we're talking about an unknown angle, we're not going to use the letter X. We're going to use the Greek letter of the alphabet, theta. Now, theta looks like a 0 with a line through it. Theta is 0 with a line straight through it. Now, be very careful of that, drawing that theta. That is not like the symbol for no solution that you used in college algebra with solving equations and not getting an answer. Remember, a no solution is a 0 with a slash through it. That is not what a theta is. So these angles, when we draw an angle in standard position and we don't know its actual measurement, we just label it with the Greek letter theta, just so you know. Okay, so here are 4 examples in your notes. Example 6, B, D, F, and H. We're going to do 4 of them, just to make sure you understand how to draw an angle in standard position, because we'll be doing that throughout the semester. So if it says drawn in standard position, step 1, where does the vertex point go, guys and gals? That's right, the origin. So I'll put my vertex point at the origin. Step 2, when I draw an angle in standard position, where do I always draw my initial ray, my beginning ray? That's correct, on the positive x-axis. always. Step 3 is now to draw the terminal ray. So now we want to draw, it's very specific here, a 140-degree angle. Well, you're going to say, do I need to go get my protractor? Absolutely not. We know when we draw the x and y axis, which is, this is what this is. This is the x-axis, this is the y-axis. We know when we draw the x and y-axis, they're perpendicular to each other. Perpendicular means they meet at how many degrees? That's correct, 90. So we know each of these 4 boxes, which, what are they called? That's right, quadrants. Each of these 4 quadrants makes 90 degrees. So this is our starting place. This would be 0 degrees. If my terminal ray landed here, that would be at 90 degrees. If I have my terminal ray landed here, that would be another 90, which would make 180. If my terminal ray landed here, 90 plus 90 plus 90 would be 270. And if my terminal ray landed back to where I started, if I went all the way around, I would make a circle, which is how many degrees? 360. So to draw a 140-degree angle, we don't need a protractor. We just need to know what quadrant does that terminal ray land in. If you remember, we label the quadrants with Roman numerals. This is the first quadrant, 1. This is the second quadrant, 2. This is the third quadrant, 3. And the fourth quadrant, 4. Okay? Remember all these skills from graphing? Good. So when I want to draw a 140-degree angle, I know my terminal ray is going to land between 90 and 180. It's somewhere in quadrant 2. You do not need a protractor. You're just going to draw me a terminal ray in quadrant 2. But that picture is incorrect. You have to put the arc that connects the initial ray to the terminal ray, and then you would actually label this 140 degrees, because we actually know the angle measurement. That is how you draw an angle in standard position. All right? Let's go to 6D. I want to draw a 333-degree angle. My vertex point is at the origin. My initial ray is on the positive x-axis. If I know my units, this is 0, 90, 180, 270, 360. 333 degrees would land in what quadrant, everybody? The terminal ray. Very good. Quadrant 4. Between 270 and 360 would be 333. So I draw my terminal ray in quadrant 4. Is that picture correct? No, it's not. I have to show from the initial ray that it rotated counterclockwise all the way to there. That counterclockwise rotation tells me the angle is positive, and I'll actually label this 333 degrees. All right, 6F. I want to draw an angle that's negative 265 degrees. Wait a minute, that angle's negative. Step 1 and 2 are the same. You put your vertex point at the origin. You put your initial ray on the positive x-axis. What's different is you're not going to rotate counterclockwise. You're going to rotate clockwise. So if you want, label. This is still 0 degrees. But if we're going clockwise, if we go here, this would be negative 90 degrees. Then if I landed here, this would be negative 180 degrees. Negative 270 degrees, negative 360 degrees. So all we're doing is counting the quadrants backwards. So if I ask you what quadrant would the terminal ray lie in for negative 265, it would be in quadrant 2, between negative 180 and negative 270. Here's the key. Right now, if I look at that angle, if I don't put the arc, I don't know which way you rotate it. I don't know if it's positive or negative. So I have to put the arc. I always put the arc starting at the initial ray, going to the terminal ray. That shows me a clockwise rotation, which means that angle is negative 265 degrees. Isn't that cool? All right, let's do one more. This angle is negative 1,010 degrees. So again, it doesn't matter how big or how small the angle is, we can draw it in standard position. Step 1, where is your vertex point? Origin. Step 2, where is always your initial ray? Positive x-axis. Step 3, now we got to figure out what the terminal ray is. Well, it's a negative angle, so we're going clockwise. So this is 0 degrees, negative 90 degrees, negative 180, negative 270, negative 360. Now, what happens is we're going to negative 1,010 degrees. So we got to keep counting backwards. So if you look at this, these are multiples of 90, all these angles. That means they're multiples of 9. So you know your 9 times tables. 9 times 1 is 9. 9 times 2 is 18. 9 times 3 is 27. 9 times 4 is 36. So this would be 9 times 5. This is negative 450. This is 9 times 6, negative 540. This is 9 times 7, negative 630. 9 times 8, negative 720. Still not enough. 9 times 9, negative 810. 9 times 10, negative 900. 9 times 11, negative 990. 9 times 12. 9 times 12 is 108. So 90 times 12 is negative 1,080. So that's what we're doing here. When we go around, we're doing multiples of 9 or multiples of 90. So now we know that if we look for where our terminal ray is going to land, it's going to land between negative 990 and negative 1080. So it's going to land in quadrant 1. Now, here's the catch. We have to show that we counted around many times. In fact, we counted around almost 3 times. If you watch the rotation of the arch, you start at the initial ray. We're going negative angle, so we're going clockwise. So watch, we're going to go all the way around once because that was 360. Don't land it back where you started. Leave a space because you went all the way around again. That's negative 720. Then you kept going. From negative 720, it was negative 810, negative 900, negative 990, and that's where you got to the negative 1010. So I should see all those rotations, those spirals. If I don't, then you graphed it incorrectly. I'll label it. So now we learned in trigonometry, angles are not just going to be positive, angles are going to be negative. Now I know what you're thinking. You're saying, well, we're going to have to draw an angle that's also in minutes. Well, yeah. The only difference is, if it's in minutes, you're just still worried about what quadrant you're in. It's not going to make any difference in drawing the actual angle, because remember, we're not drawing these precisely with protractors. We're just estimating what quadrant it is. So if I gave you an angle that was 15 degrees, 42 minutes, you know that would be in quadrant 1. Okay. We'll continue on with more of this in our next video. Thanks.